to another Scala Space podcast. Today with me, I have two Scala developers, both experienced and both very fun. First with me is Igal Tabachnik, a developer who wrote IntelliJ plugins, and most notably Zio for IntelliJ plugin, which helps with all the typing stuff that you can have in Zio. And the second one is Jędrzej, who is my colleague from VirtusLab and is also a contributor to Scala compiler and medals. So our topic for today is the future of Scala IDEs. And we wanted to talk about new developments in this area, new experiments, and things that are becoming a new reality, things that can be done, things that are made possible in the near future. So coming from that, I would like to ask you, Igal, about the current state of IntelliJ. You have the most experience here with this side of the story, and could you tell us briefly what the state of IntelliJ Scala is?
All right. Well, first of all, thank you very much for having me here. It's a real pleasure. So I've been a power user of IntelliJ for a very long time for various reasons, and wrote some plugins into that. So I have some perspective into some inner workings of IntelliJ, but I want to emphasize upfront that I'm speaking from personal experience, and all of this is my personal opinion, and speculations in no way reflect the actual things that JetBrains are working on. And so with that, I wanted to say that historically, IntelliJ is a giant ecosystem that lets you build languages on top of it. Basically, everything in IntelliJ, every language support is a plugin. So everything could be extended and implemented. They have a basic layer on top of which they build every language. And historically, what they did is, in order for them to support all of their features efficiently and effectively, they're essentially re-implemented most of the compilers into their own representation. This means that for most languages out there, IntelliJ does not invoke the actual compiler to do analysis and to do stuff like syntax highlighting and type resolution, but instead they do it themselves and store everything in caches and in memory, and building indices that I'm sure many of you have seen at one point or another, in order to interact with the code without actually delegating to the compiler for performing analysis. And they've done this historically for performance reasons, for the latency that you sometimes have when you need to invoke a compilation step and wait for the results. And for the most part, this worked really well, and this continues to work really well, including for Scala. Now, Scala is notoriously a difficult language to support, but they've done that, and in the recent years, the support has greatly improved. So there are very few, if at all, false positives that historically happened, and this is, of course, because Scala support was kind of re-implemented by JetBrains and not using the real compiler. So sometimes the compiler and what you see on the screen are not in agreement. But in the recent years, I truly believe that it's greatly improved. And now with Scala 3, they actually are using the real Scala compiler for some things, in particular error diagnostics and error highlighting, that actually give you much higher fidelity for the features and for what you see on the screen. So it's much closer to the truth. Now, of course, there are some downsides to that as well, which we'll cover very shortly.
Okay.
So
what are the biggest, impactful points of doing this? What is the what are the benefits of doing this the way that JetBrains did it?
Right. So one of the benefits, as I mentioned, is probably in terms of something that's called error recovery. So this means that when you type code, every time you type something, IntelliJ immediately reanalyzes it, and it's able to inspect the state of your code And if you're in the middle of typing and things are not really compiling yet, it will immediately highlight all the errors in your code and all the things that are not currently resolved. This greatly affects the speed of development, the feedback that you get, that you're still kind of, your code is still kind of not in compiling state. And in addition, because of that, you have other features that are supported from IntelliJ, even if your code is not compiling. So you can still have navigation, you can still have, you can still import stuff, you can still refactor a code that's actually read. You can still move it around with the refactoring tools. And this is, of course, because their representation is in memory. It does not need to ask the compiler, give me, like, compile this code for me and tell me if it's okay or not. In fact, this is one of the limitations, is that code that does not compile, the compiler will not probably give you the full information that you can display. We'll talk about that in a little bit. In fact, I want to show this error recovery in action. So I'm going to share my screen, and I want to show you the little difference that you can see. So I'm going to present my screen now, and I'm going to switch to IntelliJ. You can see this, right? So here I have the tiniest application. So this creates a class person, which declared somewhere else. In fact, I'm going to open this up, and I'm going to split this into two tabs like this. So what happens is, this is Scala 2. Now, for Scala 2, everything happens in memory. So the moment I change the code in such a way that it no longer compiles, so for example, I'm going to erase a character right now, everything immediately becomes read across all files in the project, so across all modules. So without saving, just by removing one character, everything is painted in red. So IntelliJ knows that right now I'm not in a compiling state, and this is without performing any compilation. This is all done by IntelliJ in memory. Now, if I switch to Scala 3, I have another project here that's running Scala 3, and I have a very similar setup. And I'm going to open this file, and you can see I already tried this before. But I'm going to do something very similar. I'm going to erase one character. Now, what happens is, it's maybe very hard to see in the video, but first of all, there's a slight delay. So when I remove this, things happening not immediately. There's maybe a second or half a second of delay that's happening here. That's one thing. So it knows that in this file, this symbol person is no longer valid, so it paints it in red. And this squiggly is just for the typo detection. But notice that here in the main, this element is not highlighted. This is white right now. And Scala has no idea what this is. Because, and this is my guess right now, that the Scala compiler did not provide any information to IntelliJ about the status of this file from main, because this file is not compiling. Okay, so it doesn't propagate this error information everywhere. To demonstrate the difference is that the Scala 3 by default delegates to the compiler, but you can switch this off in settings. If you go to the settings and in the editor, you can select the error compiler, the error highlighting, to use the built-in rules. And when you do this, even in Scala 3, you have the immediate feedback just as it was in Scala 2. But of course, there are downsides to all of this. And right now, I'm going to switch it back to the compiler so I don't forget. And I'm going to stop sharing. And one of the downsides, so the benefits are, of course, that you have much more responsive feedback when you're writing code. The downsides, of course, is because Scala had to re-implement, IntelliJ, the Scala team at IntelliJ basically had to re-implement a lot of the functionality. There are some things that they just literally technically cannot implement. One of the major examples of this is macro support. So macros is something that only the compiler is aware of, and it does not expose. There's not enough information for JetBrains to support macros correctly. For Scala 2, there's some hooks in the IDE, so you can write custom support for macros. But in Scala 3, is even worse because of the inclusion of a new feature in Scala 3 called transparent inlines, which lets you write macros as as a first-class citizen. Whereas in Scala 2, macros were always declared experimental. In Scala 3, this is kind of a first-class citizen, which many libraries now use And unfortunately, IntelliJ cannot really display those things correctly. It will not infer the types produced by those macros, so it will be inferred as any in most cases. And this is why you will not get any helpful completion or helpful compilation hints, or even syntax highlighting will probably not work. And this is one of the downsides of not using the real compiler directly for those things. But we, as we will find pretty soon, there might be improvements in that area. So with that, I would like to pass it along to, well, back to you, Łukasz, to hear about how Metals does this.
Yeah, I just wanted to interrupt you, because as a long-term Metals user, I do have this experience of type providers being awesome. So you can write transparent inline macros that generate types in the compilation.
Yeah.
And it is impossible for any tooling that doesn't interact with the compiler to know what is the type coming from this. So, Jędrzej, it's a question to you. Could you describe how this is possible on the Metals side? How Metals is integrated with the compiler, that it is possible, and what are the upsides and downsides of that?
Yes, so maybe let me start with the basis what is a Metals, because people may not be aware that there is a second IDE which is working for Scala developers. So Metals is kind of a different story than IntelliJ. It is not a big ecosystem. It is rather a smaller implementation, a backend for your language support. And it can be used in various clients, such as Visual Studio Code or NeoVim, or even the new IDEs such as Z, Helix. They all support language server protocol, and this is how it communicates with the backend. So Metals is something smaller. It is, as I said, not a part of something bigger. It's small, independent part, which is only supporting Scala. So with this, we went for a bit different solution because, as Igal stated, IntelliJ have their own re-implementation of the compiler for various reasons. We went for a different solution which uses the real Scala compiler, the same one that is running behind Scala build tool or other Gradle. Yeah, basically, this allowed us to support the features such as transparent line macros. As I said, this is the true Scala compiler, which only cuts few phases. It runs front-end phases and skips the rest, and it allows us to have correct representation. It is the same as the compiler will output it to other tools. So this is a giant benefit to have, because as developers, we need to have solid knowledge about our code. And this is the only way to guarantee that the stuff that IDE is showing you, displaying it to you, is correct, the same as it is represented internally in the compiler. And this had a small drawback, the solution that we've chosen, because our solution doesn't store anything in memory. It is using the real compiler, and compiler have different phases, front-end phases and then back-end phases, which creates compilation outputs. In Scala, it's class files and tasty files, and those phases are actually not run if your project is not compiling. We have no class files. That means that sometimes when you are working with partially not compiling project, we will not have information about those files that are not compiling. So we've had some brainstorm, and we basically came up with something clever called best effort compilation, and it reuses another stuff that was created for Scala 3. It's called Tasty. So let me quickly introduce Tasty, because this is very important for the future of Scala. This is the typed abstract syntax tree. This is basically a Tasty. But what it means, it's the internal representation of the compiler with proper types, which is dumped to the file system, which then can be reused by other tools, such as compiler, or even Metals, or for some analysis, which can also be done. So this is a great utility to have, and we will leverage Tasty to allow us to work with non-compiling projects by providing the best effort compilation. And best effort compilation basically allows us for early compilation outputs. Even if your project is not compiling, it will still create partially not correct tasty files, which are called btasty, best effort compilation. And this allows us to have information about non-compiling projects. And let me demo it for you, because it may sound complicated, and the result is something that is most important here. So let me find this should be it here. Can you see the screen?
Yes.
Yes.
Okay, so this is very, very small Scala project. And as you can see, it consists of two modules, module A and module B. Let me show the build.sbt file. It is very, very simple. What is important here is that module A is used by module B. Module B depends on module A. And right now, we are not having any best effort compilation. So let me simulate changes which will make module A not compiling. So I have this API object which provides us with get module name and missing given method. And as you can see, we have two compilation errors. But we want to use those methods, or we are already using them in our other projects, and we would like to complete this. So let me try to do this. Module A, and we see nothing, right? There is no completion for module A. I can even try to write this module A test. How this method was called? Once again, it was called get module A name. And what is important here, we are not even getting the diagnostics, because it is not compiling as dependent project is not compiling. It is not propagating further. So best effort compilation will be triggered in this build by changing Scala version to the latest one, because it is a change which was implemented internally in the compiler. We have to bump Scala version to support it. So let me quickly swap it for the latest Scala RC version and import the build, metals, import build. And after a few seconds, if we go to the same file, we can still see that there are errors here. One is the missing type, one is the incorrect type. And now if you try to use it here, let me try to complete this module. We can see the module here. There is no package defined, so it's empty. It says it's empty. But if we go and try to complete the members of this object, we will get both module A and missing given method, and we can complete this. Everything is fine. Let's say I will make a compilation error here. There is no such name as get module A name. We have proper diagnostics, despite our project, which we depend on, is still providing us with errors. But what is super nice here is even changing and fixing those issues right now will allow us to quickly see the results in the IDE. So right now you can see that there is a get module A name. It was cached, but if I re-ask the compiler for the completions for missing given, it no longer says any. It is non-existing type. And if we change this to, let's say, a string, it will also instantly say that this is no longer a non-existing type. This is a string. So everything is updated dynamically. And those methods which are non-compiling, as we had in the beginning, so the type was actually non-existing, we just had any. So it is still better than nothing, but not actually super useful for us. But we still have the completions. So it's a win-win. So that's btasty demo. And it is a big game changer for the future of Scala IDE for metals, as we will have a good support for projects which are non-compiling. And this is actually not so rare to have a changing branch, updating a module. It's a common thing to do. And right now, we will have support for it. And yeah.
So when are we getting that? Well, that's the question.
As you saw, I had to switch to the latest release candidate. I think Nightly already has it. And it will be shipped in 3.5.0. And that's for our mainline. And for LTS, it will be shipped in a near future. I can't tell you the exact date, but it will probably be shipped to the LTS, so all users could benefit from this. And as Scala provides you with is backward compatible, you should always stay on the latest version and enjoy the better IDE experience. And yeah, that's it about btasty. Yeah.
This is really great. From my perspective, this is exactly the kind of thing that I personally was missing when using. And by the way, just so I'm clear, you were using Metals, only you were using Vim instead of like VS Code, because Metals is just a language server that you can plug into any editor.
Yes, exactly.
And this is what happened. And all you did was just bumped a Scala version, right? You used.
Yes, I only had to change the Scala version because I already released the PR branch for the Metals, because Metals haven't merged the support for btaste yet. It will be merged probably next week. It is almost done. We are just waiting for a CI to pass. And yeah.
Okay, so this is happening really soon, right?
Yes, it is happening really soon. So if you are not on the latest version, Scala 3.5.0 should be also released very, very soon, like 2 weeks or one. You can try it for yourself using Metals, and see if it helps in your case. If not, feel free to always report issues. That's the way for us to know that there is something to improve. And without the issues, we don't know that something is not working. So.
Sure. Yeah, it's a game changer for me. I'm a bit salty because it's coming to 3.5, and I'm mostly maintaining libraries now, so I have to wait for the LTS backport. But having that in application code, that looks really, really nice. But I have a question.
Yeah, sure. Yeah,
no?
sorry. So LTS means 3.3?
Yeah.
So it's going to be backported to 3.3. Okay.
Yes.
That's
probably 99%.
Cool. Okay, yeah. I wanted to continue in the same vein. So, Igal, do you see any ways, having your knowledge, not developer at JetBrains, but long-term power user of IntelliJ, do you see any way for IDEA to benefit from this development?
Absolutely. I mean, personally, right now, a light bulb went in my head that this little btasty demo would actually solve this little highlighting issue that I just demonstrated when switching to Scala 3, because the compiler, the output of btasty, would provide you with more highlight information for other things, for other modules. So we would highlight that person inside the main file. Instead of being white, it would be fully red, non-compiling symbol, which is very important for developer like visual feedback. Like IntelliJ knows that something is broken there, but you as a developer don't really see it because it's white. So this is going to be very beneficial. Now, as I mentioned before, this is mostly speculation, but the way I know that this currently works is that Scala for IntelliJ for Scala 3 projects uses the real compiler, or as it's more commonly known, the presentation compiler, to just for the error highlighting stage. It does not use it for anything else currently, and if it cannot do it, it falls back to its own internal heuristics, just as we saw. But what we saw here is that it opens a possibility for definitely enrich IntelliJ with the information from the real compiler, because it's kind of deep. I'm not sure if it's even a public API, but because IntelliJ already today knows how to compile and read the tasty output, this is just a matter of enriching it. Now, whether or not it would be possible to do externally by means of implementing some plugin, for example, because everything can be kind of intercepted and augmented in IntelliJ. The API is really rich in that regard. And if not, this is definitely something that the team at IntelliJ at JetBrains could probably do. If we open a pull request or if we open an issue saying Scala 3.5 and above now supports this btasty format, maybe it would be possible to use it. I'm sure if this conversation starts, they could definitely consider it. Now, having said this, is that I want to kind of move into the little bit of experimentation that we did, that I initially wanted to see whether or not it would be possible to implement metals inside IntelliJ by using LSP. So LSP for those who are not really familiar, LSP is this protocol that allows talking to the language server, to Metals. And this is how, for example, Metals was able to be integrated into Vim. So LSP allows integrating language servers into any editor whatsoever. So IntelliJ recently shipped support for LSP. It's only in the Ultimate Edition, but there are another LSP alternatives implementations available. So what I wanted to do is I wanted to see if I could have IntelliJ talk to Metals and recover some additional information from it. In particular, I wanted to see if it can resolve the macros, the things that we talked about that were missing earlier, if it can do that. I want to say that I succeeded. There were some initial successes. Of course, it's not really perfect, and I had to kind of dig deep into the macro resolution facilities of IntelliJ to support it. But I was happy that it was kind of successful. But then, as it turned out, I met Jędrzej, and we realized that using LSP inside of IntelliJ with Metals running on the backend it's very, very expensive. It's like, in terms of both performance and just the memory, you were essentially loading your project and all the metadata twice into memory. So that's not really something that we want to do. And then we started talking, and then we realized that we could use parts of what powers Metals, the parts that are coming from Metals, the presentation compiler, to supplement and to augment and to enrich the things that are provided in IntelliJ without actually doing the heavy lifting of using LSP. And with that, I would actually like to ask Jędrzej about your opinions on whether or not this was possible or successful. And
yeah. So we did the experiment, right? We tried to do this, and I would say we succeeded. We had two different prototypes. I will show them to you in a few seconds, but let me quickly describe what they were trying to achieve. One of them was basically a trial in which we plugged Scala presentation compiler, the heart of the completions, heart of the hover, the thing that actually computes them, directly to the IntelliJ, with skipping all this LSP stuff. Let's ignore the LSP connection with the server, all the build tool stuff, and just try to reuse the thingies we can get from the IntelliJ. So presentation compiler requires few things. First of them is the build definition. We need the Scala version. We need to know the flags. We need to know Java flags. This is very, very important to have proper completions and proper outputs from the presentation compiler. The second thing is to actually have data to work with, and this data is a class path. And there are two problems with this. First, getting the class path and then populating the class path. So getting the class path was actually super trivial in IntelliJ. It does it for us because it supports reading the SBT configuration. We can just get the class path directly. But how do we populate it? Metals do it via the BSP, Build Server Protocol. It runs another server in the background which tries to compile your project, and this server creates class files which are then used by the presentation compiler. And this is like another server that we had to do, but that's how it was implemented and designed in mind. So how did we solve this? It turns out that the compiler diagnostics, which Igal showcased previously, are doing this for us for free because they are using the real compiler, and this real compiler actually runs backend phases and they populate the class path. So we can run compiler diagnostics in IntelliJ. They will create class files for us, and then we will consume them in Metals, in this prototype. Sorry, this is not Metals. This is another hacky experiment in the real Scala presentation compiler to get completions which are true for your configuration and for your setup.
Okay,
so this was the first.
Let me interrupt you for a moment. So let me get this correctly. IntelliJ, the option that Igal has shown before, it uses the full compiler with all the phases.
Yes. It has to, because it provides, it creates the class files. I mean, maybe I think it runs the full compilation because class files are actually generated in those folders.
So
when
is
the
that
compiler
the reason for the
diagnostic mode is
slowdown
on.
that Igal was mentioning? That
Yes, probably yes. It's
Ah.
the same thing we have in metals, right? We communicate with build tool, and it is running a bit slower than IntelliJ built-in memory representation.
yeah,
It is not
yeah,
instant.
it has to write to disk, right?
And
Yes.
yeah, in fact, it has to be saved, right? The changes has to be saved with the command S to actually trigger the build. Yeah.
Okay.
So this is also another area, but I don't know if I should delve into this. This can also be solved in metals because presentation compiler runs 3 phases or just front-end phases and comments hooking, which creates hyperlinks. This is not important. But what is important is that with those front-end phases, we can get most errors straight by providing you with completions. So whenever you type something, we can also get diagnostics for this compilation. And this is also the true compilation output, the same one you will get, maybe not full because it will not run all the later phases, but partially correct compilation output. And we can show this information instantly to the user by just getting it from the compiler. We are not doing it right now. It has few problems, but we will probably ship it soon or sooner. We don't know. This is another experiment. This is not important here. This is just a mention that we are trying to solve this too. But let me go back to the first topic. So this is the first experiment in which we try to plug the Scala presentation compiler, which is provided by the compiler. It is bundled together as the Scala library. It is part of the compilation pipeline release process. And then we are trying to plug it into IntelliJ. And it worked. It was working fine. And it solved most of the issues with the transparent line macros. But there is another story behind this because macros are not the only thing you need from the IDE. You also need to know the symbols available in your scope. And metals do it by providing you with symbol search. So IntelliJ has its own implementation of symbol search. Luckily, presentation compiler was designed in a way that we can plug any symbol search we want. So if we could create a wrapper around IntelliJ symbol search and use its indexes to get completions in metals, we will have a big new plugin which has true output, true completions, and reuses IntelliJ indexes. So there is no work duplicated because presentation compiler is kind of fast. It is not super heavy because everything is provided for us by IntelliJ. It already does it. And yeah, with those building blocks, we created something which I'm going to show you right now. Okay, can you see the screen?
Yes.
Yes.
Okay, so right here, the blue IDE is IntelliJ. And I opened here the SCSI, and let's try to get some completions, right? It will just work. It is normal IntelliJ experience. Everything is fine. And just to showcase you that metals can be plugged directly into IntelliJ, we've created a plugin which basically overrides the implementation of the completion, just completions for now, because it is not so trivial. It requires work. It was rather than an experiment than an actual trial to replace IntelliJ plugin. This is the same project, same code. As you can see, the edits are still here. Let's try to do the same thing. And right now, we are using the completions coming from metals. As you can see, they are a bit different.
Definitely
right here,
looks different, yeah.
Yeah, they look different because they are not colored in the same way. I think they can be aligned, but it wasn't the point of this experiment to align the visual part of the completions. The clue was to run the official Scala free presentation compiler as a backend for completions in IntelliJ. So we can see that everything is working fine, and it even works for symbol search. So symbol search, let me go back to the first IDE, is something that we can do by writing capital letters in IntelliJ. So let's say we want to access concurrent map. We can write concurrent, and you can see even if this thing is not in scope, it is not important anywhere, we can still see this as the completion because it was found as a match in the index, in the database.
Okay.
And if we get this, we have auto completions, right? So I tried to bundle this index of IntelliJ into the index of metals, and we can do the same thing here. And let me try. It was concurrent map, right? Concurrent map. It's still here. It's displayed differently, as we said. And this will also solve the issue with transparent inline macros. I don't have snippet ready for this, but it will also solve issue with this because it is the real compilation running underneath with full knowledge of types computed during the
So
type run.
just so I understand this completely, what you've done. So this is a plugin that you had to write that does not
Yes.
replace the original. We will talk about this in the end. There is no way to completely replace the Scala plugin that's in IntelliJ. It's tightly integrated into IntelliJ, and some of these things we will never be able to replace. But what's happening here, if I understand that you created basically you implemented a completion provider. This is a part of the Scala, the JetBrains SDK. And this completion provider goes and uses the presentation compiler, so essentially the real compiler, to ask for all available symbols to give at this point. And this is what you would get if you were using it from Metals.
Yes, exactly. This will be almost the same because Metals has its own indexes. Indexes can be a bit different, right? There can be implementation differences in how IntelliJ builds indexes and how Metals build indexes. But the clue is that we somehow bundle them together and build a new completion provider on top of existing IntelliJ features. So as you said, this is exactly it. It is IntelliJ with compilations computed by Scala-free presentation compiler, the backend of Metals.
Okay, so should we think about this experiment as an extension to Scala plugin to IntelliJ, like a plugin for a plugin?
I mean, well, if community will want something like this, and we will see enthusiasm and maybe some community effort to help this happen, it may be the case, because what is very, very good about Metals is actually the backend, the Scala-free presentation compiler. It is super well polished. It is working very, very good. It is very, very fast. And I would say this is the most stable, most maintained part of the IDE we have right now. So using it is, I think, a good way. It would also make a single source of completions for all IDEs, right? We could then work together on the same implementation, because right now IntelliJ works on its own completions, Metals works on Scala-free presentation compiler. It would be great if we could bundle our strengths together and create even better experience for all of us, because I don't think that Metals and IntelliJ is in some kind of rivalization. It's two different ecosystems built for different use cases for different people.
Yeah, sure. I fully agree. This is really, really exciting development, and I hate to be a buzzkill, but it is something that I can't avoid. I have to ask, what is the story with versioning? Because with IntelliJ, my experience always was that they handle Scala versioning problems on their side. So if we had multiple versions of Scala language in the same project, let's say, it was transparent to the user. In the end, you just don't care as a user which version is used in which module, and Scala plugin basically works for all of them. If you have modules that use Scala 2, they work better. If you have modules with Scala 3, they have some hiccups, especially with the new features and new possible combinations of features. That's understandable, right? But it's on their side. The ball is on their side of the ball. So what is the actual story if we wanted to do this with versioning of Scala packages? What happens if we had, let's say, Scala 3.2 package? Would this work? Because if I understood you correctly before, you mentioned that the presentation compiler is part of the compiler, and compiler is versioned by language versions, right? So it's coming in 3.5. What about the older versions? Would that work?
Okay, so let me quickly explain what I meant by is bundled together. So presentation compiler uses internals of the compiler. It uses the internal representation, and this representation can evolve over time. And it's internal, right? That's the natural thing that happens. So we went into a conclusion that we should bundle and release them together. So each version of the compiler has its own specific presentation compiler. So let's say we have Scala 3.3.3. it has its own presentation compiler released for it, and there will be no updates for it in the future. You will have to bump the Scala version. That's the price that we pay. But with Scala-free binary compatibility guarantees, that shouldn't be a problem. You should try to stay on the latest version if you can, because LTS is backward compatible. I think in both binary and source level.
Yeah, that's a good news for end users, programmers who use Scala for development of business applications. But for library maintainers, the only hope, if I understand you correctly, is that the backport of btasty comes back to LTS branch, right?
Okay, so this is the btasty part, right?
Yeah.
Because if we talk about the presentation compiler improvements, we always backport all of them. I mean, there is no exclusion. All
Really?
PRs that happen on the mainline, we backport all of them to the latest version. Yes, because we haven't had any problems with it yet. If we will have any problems, we will maybe then reconsider this. Right now, everything is working as intended. So we try to go and bump LTS IDE support to the latest stable version from the mainline.
So all the changes to presentation compiler happening on, let's say, 3.5 branch are coming back to LTS.
Yes.
Oh, nice.
All changes, and I think as LTS, I think is also going to be released very, very soon. It is up to date to the 3.5.0. It will be on par in terms of the features. So as you can see, it is all only for the IDE part, right? The compiler is not part of it. Compiler is more strict because it's LTS line. We only backport the necessary stuff, the critical fixes, optimizations, not all the stuff. But for IDE, we can backport everything. Everything is also, this is possible because presentation compiler is basically an interface, and we have MIMA set up for it, and we just can't break it. I mean, it's very, very hard to break it. So we just load it with service loaders. So now I can go and answer your question, because you said how it will work with different Scala versions, right?
Yeah.
So right now on the screen, you can see the internals of this plugin for the IntelliJ. It is not super big, as you can see, just a few Scala files. And in the PC completion provider part, we need something called presentation compiler. So I have this service created and method get presentation compiler. And what it does, it basically is the map which holds a module as a key, and the value is the presentation compiler released for this version. So each module that you have will have its own presentation compiler. It is also necessary because there is not only a Scala version, going into presentation compiler. There are Java flags, Scala flags, class paths. You have to separate them. As I mentioned previously, presentation compiler requires all of them to provide with correct output. Let's say you have additional dependency on the class path. You will see extra completions, despite they are not actually present in your module. So presentation compiler will see something, but the real compiler run by SBT won't see it because you passed incorrect configuration, incorrect setup. That's why we have this map. And each instance, each module that you're working on, it will be populated dynamically, not instantly for all modules. You just download, load it with service loader, and then you will have this support, right?
Okay, so my last nitpick that I have. I promise it's the last one. So what happens if the module has Scala version set to 2? Let's say 2.13.
Okay, so 2.13 is Scala 2, and I'm talking about Scala 3. I've been talking about Scala 3.
Okay, so it's exclusive.
For now. I mean, not yet, no, because this is kind of tricky. In Scala 3, maybe let me change the narrative. So there is a presentation compiler, and it was always a part of the LSP implementation we've had. We've had Scala IDE, we had Metals, we had Dotty language server, and for some time, the implementation of presentation compiler was located directly in the compiler. But after some time, it was moved to Metals. It was removed as Dotty language server was deprecated and moved back to the Metals. And then it was moved back to the compiler because it was a mistake. And we wanted this equality of compiler internals and the stuff that we are working on.
Yeah, makes sense.
And that led us that Scala 3 right now, from version 3.3.0, has its own presentation compiler. They are not present for 3.2.0, but I said that we migrated them from metals to presentation compiler. So metals have presentations compilers. So I'm not calling them Scala 3 presentation compilers. They're called MTACs, but they are basically the same thing. They're re-implemented for some features. They had to be, but they're exactly implementing the same implementation, this presentation compiler abstract class, which provides you with the completions, with the item resolving, signature help, hovers. So as long as you have something that implements this class, you can load it. And actually, MTAGs are released for Scala 2.12, 2.13, and yeah, you can just have it all together.
So-
And the fetching part is, this is just a change in an artifact name. You don't download org.scala Scala 3 presentation compiler. You just download metals MTAGs for specific compiler version. Always for
Okay.
specific compiler version. As I said, they have to be binary compatible.
Okay, this sounds helpful.
I wanted to ask about this file that we're seeing on the screen. So this is the interface essentially to the presentation compiler, right? So you can implement it, and I see so many useful things here for like from a tooling perspective. It gets you everything. Like I see, it gets you completions. If you get back a completion list, you get back signature help. So hover gives you back type information, the thing you see on the tooltip. So it reminds me of the LSP API, but this is a library. This is something that's can be called directly without the need to use a protocol. And
Yes.
So this is fantastic. Now, just going back a little bit to this overall idea of making a plugin for a plugin. From my perspective, as somebody who's done that, I've built plugins for plugins in IntelliJ. There's some technical issues that are challenging about this. First of all, you have to find all the extension points to override. First, the completion provider is kind of a more supported feature because you can implement your own languages. So you obviously want to provide your own code completions. So you have completion providers. For other things that you would want to support, for example, error highlighting. There are some error highlight. It's all run in stages. There are error highlighting stages. I'm not 100% sure how pluggable that is because it's very tightly coupled to how actually Scala runs it. So we need to do some more experimentation, looking if it can be overridden. And there are many other hooks that could be utilized from presentation compiler. Now, whether or not this is it only can be a plugin for a plugin. So like I mentioned, the Scala compiler, the Scala plugin in IntelliJ is not going to go anywhere because it's tightly integrated into the ecosystem that's IntelliJ. It cannot be removed or replaced with anything. But it can be augmented using these hooks, using these APIs. And I think this gives an amazing opt-in experience for people who are more adventurous and they want to experiment by enabling even more features from the real compiler rather than just error highlighting. They can enable completions. They can enable other things that I currently cannot think of, maybe signature hints with hover that would give you a much richer information, for example, for things that IntelliJ doesn't understand, like transparent inlines, stuff like that. And I definitely envision this as an at least community effort to build something like this. And again, not speaking at any capacity for JetBrains or what their goals are. If one day they can see that these experiments are successful, then maybe they will choose to integrate some of these things into the plugin. So it will just enrich the experience for everybody. And that's it. So I'm really excited about this development. I would really love to see it going open source. And although there are about 20 people in the Scala world that know how to deal with IntelliJ plugins, who also contribute to open source, I'm pretty sure this can be managed.
Yes. I only like to add that this idea of augmenting is, I think, a very nice approach to go further with this experiment, because it could be a fallback for the stuff that IntelliJ can't understand. Or IntelliJ could be fallback for this. You can be the both ways, and it could also solve the issue with macros, right? If you see that something is it's a good guess that well, maybe try using the real compiler to get the types for you. And yeah, that's very, very promising. I will stop the share screen right now. I think there's
and one more thing to mention is that the reason it kind of has to be, well, at least for the time being, a plugin for a plugin, because it has to kind of piggyback off what the IntelliJ already does, which means running a real compilation for you. Because it currently only works if there are tasty files available or be tasty in the future, which means it has to run at least some compilation step for you to generate the class path and generate the target files. So it always has to kind of piggyback or consume what IntelliJ already does. So it's always about augmentation.
Yeah, yes, because if you would want to skip this part of augmenting, you would basically want to plug metals into IntelliJ, and it is already possible. There are various LSP plugins that can achieve this. There is official LSP plugin made by JetBrains with the Ultimate license. You can just start metals with it, and it should work. I'm not sure if it was working, but it should work.
It does completions, it does syntax highlighting, hovers, everything.
There is also LSP for IntelliJ plugin made by the Red Hat, which even has metal setup guide in the documentation, which is all a third party, I would say, implementation of LSP for IntelliJ. So if you want metals in IntelliJ, there are different ways to get this. But as Igal stated, IntelliJ is a big ecosystem. It is not only the part that you're editing. The integration with other languages like Java, it is all built upon the indexes and that stuff. And by using LSP, you will not have this. So you may not see the symbols in Java projects from Scala. You may lose other features. And yeah, you will also lose those very, very good insights that, you used list.head option dot map or something, or filter, and it said you can just use find, don't use head option filter, and you will also lose this because it is all based on PSI, the internal representation of IntelliJ. So you can't exactly dump the IntelliJ. It is a different tool for different people. It is a big ecosystem, but well, you can still augment this. Augmenting, I think, is the way to go.
Yeah, looks very promising, and I'm hopeful. I just had a brainwave that there for a moment that I worried about Scala 2 support, but Igal, you mentioned that the compilation support for error reporting, it's only done for Scala 3, right? It's not. It's not
just for Scala 3.
So Scala 2 would just work based on.
I think well. There's two answers to this. There's some ways to use, I believe, well, not Zinc. It's already uses Zinc, but there is a way to switch this for Scala 2, but it would actually have to. It's non-performant, so this is why it's not recommended. In my opinion, Scala 2 support, as much as it is, it's done. It's not going to be improved. So micro libraries, such as they are, would either have to provide their own support or just move to Scala 3. So, for example, IntelliJ ships with custom support for a couple of shapeless stuff, for the new type macro, and I believe for Scala Z deriving. And there are a couple of third-party libraries that ship their own kind of plugin into IntelliJ to teach them about this macro. But this has to be a very, very specific support. And in my opinion, it's not worth anymore. Like, it would be very, very difficult, if not impossible, to try and backport support for Scala 2 for any of this. So Scala 3 forward. In fact, there's one more thing that we haven't mentioned, other than things like macros or transparent inlines. We also have to remember that Scala 3 is actively evolving all the time. And so one of the drawbacks that I kind of didn't mention early on is that the IntelliJ team, the Scala team at IntelliJ, they have to, because of the re-implementation, they have to support all of those syntax changes. So, for example, moving around or allowing you to access, putting the usings list as a first parameter list. This is a significantly breaking change that has to be manually, like actively supported inside IntelliJ. Otherwise, code that compiles will show up as red in IntelliJ because the trees, the parsers will be broken. So they always have to kind of fix that. And I believe that by delegating some of the error highlighting and syntax highlighting to the real compiler, this could be helped inside IntelliJ. So we can get an additional benefit there as well in terms of language features that just keeps getting added.
Yep, that would be very nice to try and make them work together. But there's also one other approach, which is very, very experimental. I mean, it is just the idea that we could fake PSI trees, the fake Scala IntelliJ internal representation based on the compiler output. And this is something that would solve the issues with the support with Java and other languages, but it is super hard to do, and it will take a long time to get it right. But that would basically replace the IntelliJ plugin at all, right? Because if we could use metals and fake those PSI trees, we could then ditch IntelliJ plugin.
Yeah, but I think this is science fiction. I think this won't be feasible.
That would require a team of 20 senior engineers
for several years.
Yes. Also, you would ditch all the nice stuff that IntelliJ Scala plugin has. So all the rewrites with the suggestions.
No, because you would fake those trees.
Also, they run on the trees themselves.
Yes, you still have trees, but you try to map the Scala representation back to the IntelliJ representation.
Yeah, but it doesn't really make sense that those specific, language specific rewrite hints would be part of the IntelliJ itself. They would be in Scala plugin itself, right?
You could then cut them up.
It's open source. We could borrow them.
Dissect the IntelliJ plugin and take what you want.
Yeah, but of course there's a big mismatch. And you mentioned, by the way, there's a great talk by Jędrzej. I think we should include the link somewhere in the notes for this episode. Yes. There's a great talk with a shout out to me. Thank you so much. It was really a pleasant surprise. Just first of all, showcasing a little bit how to actually achieve what we've seen here today, and also explaining a little bit of a difference between how IntelliJ does things versus how the presentation compiler does things. And the bridging of this gap, I imagine it's a ton of work. It might be possible, but let's just start with, I believe it would be beneficial just starting with plugging into existing extension points in IntelliJ and seeing if that brings additional benefit. And if we're hungry for more, I mean, it could
if there's traction, right?
Yeah. I mean, okay. I'm sure that there are big IntelliJ fans out there, because I use it primarily because I like the integrated environment, and I got used to the fact that error reporting is was real snappy for me. But then again, I'm mostly using Scala 2 still, unfortunately. But yeah, I mean, okay, this can only get better from here.
Sure. I would like to remind our viewers that it is possible to ask us questions and have our guests answer them. So unfortunately, I can't see any questions asked on either YouTube or Twitch. And I see viewers on both, so don't be shy, ask away. And I think we have covered all of the stuff that we had for today. So if we don't have any questions, we will probably be closing.
I'd like to thank Igal at this point, because he inspired me to do all this work. He was the inspiration behind my experiments.
Well, thank you so much.
I was inspired by your IntelliJ macro fix, and that led me to experiment with the rest of the stuff. So
well, thank you. And I shamelessly wanted to be on this podcast to hear a little bit more about BTasty, because that's a real significant improvement for the experience of using metals, whether or not it's VS Code or Vim or Z, which, by the way, there's Z, which I managed to contribute a small Scala support plugin based on metals. So
it's working on Linux since yesterday. So
if you want a very fast editor that's written in Rust, and it's a very, very healthy open source ecosystem, I recommend you check out Z, because it's really fast.
Blazingly fast.
Well, it's Rust. One last thing that I would like to request is that you make your experiment published on GitHub, so we can all take a look at it and improve it.
Yeah.
Of course, I will try to do this. I will try to do this, and send the link should be in the description of on Twitter maybe, or in the link on the YouTube, so somewhere. I can do this right now. It will take some time, but I promise I will do this.
Okay. We don't have any questions really. We just have a comment that says "Great job." So yeah, let's keep it up and let's try and publish this new development, this new POC. Let's hope it gets to the POC level.
PC.
So this
Presentation compiler.
yes. I got it. So let's get it published, and we'll publish a link. There will be a link on Reddit, and I will post it also to Discords in the Scala community with all the links that we have to the things that we have discussed today. And thank you so much, Igal and Je, for coming to this podcast. And see you in the future, dear Scala users. Cheers. Bye.